Okay, so for today, so I'm going to give you guys time at the end of this class, and we're going to sit down and make sure everyone has what they need in their notebook. Okay, so you'll have a little bit of time at the end of class for that. So what we're doing today is actually going to be similar triangles proof writing checklist. So we're going to do another 2-column proof. But a lot of the stuff is exactly the same as what we did last semester, but we're just adding a new way of doing it. Okay, we're just adding some new things. So we're just going to add similarity topics to what we've done already. So for what we have here, if two triangles are similar, the corresponding angles are going to be, I heard it, congruent, right? And the corresponding sides are it's part of the parallel. Depends on which type of similarity we're using. They are proportional. Probably misspelled that one. Okay, or same what? Same scale factor. So proportional or same scale factor. Okay, so that's what we need from there. We've actually had this before a couple times in our notes. So first we have to show that the two triangles are similar. Use a similarity property such as side similarity, side angle side similarity, or angle angle similarity. Those are the only ones I'm using here. So I'm going to have those. Okay, so I'm going to review what we've done for reflexive property. So reflexive property, okay, look for angles or sides that are shared, would look like this. So if I had angle A congruent to angle A, that one's going to be reflexive, right? Yes? Or if I had line segment AB congruent to line segment AB, that's a reflexive property. When I'm talking about the same thing in two different shapes. So for this one right here, multiplication property of equality. Multiplying both sides of an equation by the same number, it doesn't change the value. So if I had a problem like 4 times x over 4 equals 5 times 4. My multiplication property is actually where I'm multiplying here, both sides by the same number. That is a multiplication property there. Okay. Addition property of equality, adding the same number to both sides. So if I had a x plus 2 equals 5x plus 2. So where I'm adding the 2 to both sides, that would be the addition property there. Subtraction property would look the same, but instead of, I would be subtracting it from both sides. So if I had x minus 3 equals 5 minus 3. In this case right here, I'm subtracting 3 from both sides of the equation. Okay, segment addition postulate. So if I had a line segment, I'm going to draw a line segment here. And I'm going to call it A, B, C. Now, if I'm doing my segment addition postulate, I'm adding two segments together, right? What would the two segments that I'd be adding together be? AB and BC. Very good. So that would be line segment AB plus line segment BC. And if I were to add those two together, what would their whole segment be called? AC. Very good. That is my segment addition postulate there. So I know all you guys are writing this on your notes because you actually do need this, but you know, it's all right. So distribution property. So in this case right here, my distributing is a type of multiplication, so I have to multiply it to both numbers here, or in this case, both letters. So x times y gives me xy plus x times z, xz. There's my distribution property. And for right here, notation, the way that most proofs show that two pairs of sides have the same ratio is to write them like this. So write my ratios together. Okay, so my line segments that go together. Okay, remember we talked about corresponding sides yesterday? You know, instead of just putting numbers, we're going to put the segments for these. Alright, so this one is going to end up on top when I'm typing in my notes, because I'm going to use that to actually solve for this. Now, whenever I'm doing a two-column proof, and I know you guys have done this, I've said it so many times, probably hate me for saying it all the time. What is the very first thing I have to do in a two-column proof? Given, right? So now, in this case right here, my given is this. So, my statement 1 is going to be what was given to me here. So, my statement 1 would be triangle A, B, E with AB parallel to DC. Okay, so now we're going to go through and we're going to look at what they're talking about because we're just filling in what they have here for this. Every time we're doing this, we're usually just filling in what we're doing. So right here it says DAB, DAB. That's this angle right here. So it's angle A between D and B. So DAB is congruent to EDC. EDC. So this angle right here is going to be congruent to EDC, this one right here. Now, given this one right here, these two lines are parallel. We've done this plenty of times. These two angles right here are what types of angles? They are corresponding. Okay, if they were interior, both of them would be between my lines, right? But since this one is between the two lines, but this one is not. So they're both not inside, but I have an inside and outside. So that one's going to be corresponding. So very good on that one. So these are corresponding. So my reason 2, corresponding. So corresponding angles. Okay. Now, it's kind of missing a piece right here. So I will kind of put it in here also up with this because it's missing something before we could do that. So there's a statement that I have to make. So right here it's saying that the two triangles are similar, but I only have that this angle is congruent to this angle. Is there another angle pair that's congruent that's not marked on here? It's not given to us. I could do that. I could do that. What else could I do? It's a lot easier. Here's a hint. It's angle E. DEC would be congruent to D. So DEC would be congruent to AEB, right? Why? Do they both have the same angle? Yes. They both have the same angle, right? Since both these triangles have angle E right here in it, right? Since both triangles have angle E, I would say that angle E is congruent to angle E. So I'm going to kind of fit it in here. So angle and ABC. Oh, wait, not that one. Angle AEB is congruent to angle DEC. And that one's going to be my reflexive. So I have my reflexive for that. So that's one thing that's easy to pick out. Now they also gave you this one right here. ABC, ABC, which is this angle right here. I'm going to mark it with 3. Is congruent to DCE. DCE. That's this one right here. Now, why are these two right here going to be congruent to each other?
Because they're corresponding.
They are also corresponding. So both these together are going to be my corresponding. So I have all 3 angles in both triangles. So all I needed was 2 of them to be able to say that these two are going to be congruent, or I'm sorry, the triangles themselves are going to be similar by angle-angle similarity. So if I know it's supposed to be angle-angle similarity, now I just have to write which triangles are similar. It would be triangle. Anyone want to take a stab at it? I heard it. DEC. DEC. Okay, that'll work. DEC is similar to triangle AEB. Very good. AEB. And that uses my angle-angle similarity there. So I was able to actually get all the angles out of this, and okay, I now have that they are similar to each other. So if they're similar to each other, let's look at this checklist. If they're similar to each other, then we know that the corresponding angles are congruent and the sides are proportional. Very good. The sides are going to be proportional. So I have that AE goes with DE, right? So it's the big one over the little one equals my other side, which is BE over CE. So big one over little one. Okay, so now I was able to actually get that, and my reasoning for that one is because at this point right here, we are able to say that these triangles are similar. Because I said the triangles are similar, I say that their sides are proportional. That is my definition of similarity. So I have my definition of similarity there. Okay, so let's take a look. So segment addition postulate is my reason. So I'm going to look at my thing, and so what am I going to use for segment addition postulate here? So this side, it would be what? AD, right? Plus DE equals AE, right? A to E. So it's AD plus DE equals AE. Now let's do the other side. The other side of this would be BC plus CE equals BE. Very good. So I have my segment addition postulate there. Okay. So now, for this one right here, we're taking this information, which says it's AE is all of this, right? AE is all of this. If I look right here, this would be my AE portion, right? AD, DE, yep. Okay, over DE, and that's what I took from here, equals, but instead of writing BE, we put BC plus CE. Okay, and if I'm replacing one thing for another, what's that called? What? Transitive is a type of what we're doing, but there's a, huh? Very good, it is substitution. Okay, this one's going to be substitution because I'm replacing AE with that and BE with that. And I'm just using that same thing. So this is my substitution property. Substitution property. Okay, so now from there, okay, from there, what are we going to end up doing here? So what did I do to go from here to here? Just subtraction property. So they're able to get AD, which is what I was trying to prove here, from the very top, AD over DE, which I got here, BC over CE. So from this, we were able to actually come up with this. So using subtraction property. So what did we subtract from both sides here? Okay, we are left with AD, so we subtracted the DE from there, right? And on this one right here, we subtracted the CE. And so we ended up just coming up with the subtraction property for this one. Now, your test is going to look a whole lot like this. It has a word bank. It has everything you need for this. You're just going to fill in what you have. You have a checklist. The checklist is going to give you a lot of the stuff already of how this goes in. So if I'm looking at my practice, if you could please, let's take a look at that real quick. My practice right here, which is page 24. So I have a bunch of reasons, and I only have, let me see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There it is. It fits. So you have to use this checklist to be able to fill in those other things for your practice today. All right? Questions? Why does mine look different? Is yours turned over? Do you have this on the top, or do you have the other side?
Yeah, that's fine.
That's why. Okay? Alrighty. Don't forget, like and subscribe.